Hello everyone. In today's lesson, we will discuss how to solve a linear system of equations by using the elimination method. This is my most favorite way of solving a linear system, and I really hope it becomes your favorite too. It is very short, very straightforward, and quite easy to understand. There is a list of steps or strategies that I have written up in here, but I would prefer that we move on straight to the example and articulate the steps as we solve the system. Now, as you see here, we have a system of two linear equations, y equals x plus 4 and y equals 2 minus x. Step 1 in solving a linear system by elimination is lining up the variables. What that means is that we want the y terms to line up, we want the x terms to line up, like physically line up, and the constant terms line up. Usually what I like to do is rewrite the system with the first equation in the exact same form it's given, and then I try to match the second equation to the first one. So I'm going to get started with y here. And now I want to bring x first and then the constant after. So here is the x. It has a minus before it. And you know that this minus will go wherever x goes when you move it around in the same side of the equation. So I will rewrite it as negative x and then the constant plus 2. Now let's double check. Are they all lined up? So I see that the y's are together. Good. The x's are together. Check. And the constants are together. So we're good to go. Now this is where the fun part starts. What we want to do is eliminate one of the variables. We can either eliminate y or we can eliminate x. We have to make a choice which one we want to eliminate. And that is step number 2 of solving the system. Now, I want to eliminate the variable x. The way we eliminate the variables is by either addition or subtraction. So we either have to add both equations or subtract both equations. Now, this is when I start thinking, if I added the two equations, then y plus y is 2y, so the y term or the y variable won't be eliminated. X plus negative x is 0x, so the x is eliminated. That's what I wanted to do. So I would say that adding the two equations together will help me eliminate the variable x. Okay, and my next step is physically adding the two equations. I will write here, y plus y equals x plus negative x, and then plus 4 plus 2. So we're adding them in order. Now, y plus y equals 2y. X plus negative x is 0x, so we've eliminated the term x. And 4 plus 2 equals 6. If 2y equals 6, see how we ended up with an equation with a single variable, which makes it easier for us to solve it. Then we have y equals 6 over 2. So we got the y value equal to 3. So we'll say, hey, we got y equals 3. How about x? Well, for x, we're going to do the same thing we did with the substitution method. We can either choose the first or the second equation to work with, and we substitute the y, the value of y in either one, and that will help us find what x is. I'm going to choose the first equation, which is y equals x plus 4, and I will substitute y by 3, that's the value of y, and by solving this very simple linear equation, I have figured out here that x must equal negative 1. Therefore, we're going to say that the solution to this system of equations would be x negative 1 and y positive 3. Okay, now You're probably wondering what would have happened if I decided or if I chose to eliminate the variable y instead, not the variable x that we eliminated in this case. Okay? Actually, I want to make a note in here that we eliminated x. Why not? If we decided to eliminate y, and I'm going to rewrite the equation as it was, y equals x plus 4 and y equals negative x plus 2. So if I wanted to eliminate the variable y, addition wouldn't have helped me because by adding the two equations, I would get 2y, and what I want to get is 0y. So in this case, we use subtraction. So let's go over subtraction, just out of curiosity and just for fun, I would say. So we have y minus y equals x minus negative x plus 4 and then minus positive 2. So y minus y is equal to 0y, sorry, here. So 0y equals x minus negative x. Be very careful with this. It's very easy to get it wrong. Very often people right away say, oh, that's 0. Like x minus makes a plus. So that is technically x plus x. So that's 2x. 4 minus 2 is 2. So see how we eliminated the y variable here, okay? And then negative 2x equals positive 2x equals negative 1. And you know what? That's what we got in here, right? And we can find the value of y by using y equals x plus 4, y equals negative 1 plus 4, so y equals positive 3. So using either method, we got the same solution. And the solution to this system, we're going to say with a lot of confidence now, is negative 1 and 3. Now, I got to tell you one thing though. This was a very basic example of solving a linear system by using elimination. We're going to move on to the next example, which will hopefully bring something new to the way we solve it. Okay, the method is still the same, elimination. So let's get started. So step number 1, lining up the terms. This is actually my favorite step. So we have to line up the x's together. We have to line up the y terms together. And we have to line up the constant terms together. Okay, so as I said before, I like to keep the first equation as is and try to match the second equation to the first. So I'm going to get started with the x term in here. So x has to move to the left side, so it will become negative x. And then the y term is already in the left side, and I'm going to keep it on the same side, which means that it won't change the sign. So I will write 5y here. And the constants are already lined up for us, so which is kind of nice. So we're going to write negative 17 in here. Here goes our system. Still the same system, just change the face a little bit. Now, the next step, if you remember, is we have to make up our mind which variable do we want to eliminate. Now, this is how I make my decision. I usually check and see if I eliminated x, what makes it easier for me to eliminate it? Well, if they have either exact same coefficient or opposite coefficients, I can right away use addition or subtraction and then eliminate the variable. Now, if I did this with x, adding the two equations would help me eliminate the variable. If I really wanted to eliminate the y term here, that would be very difficult to use the addition or subtraction of the equations right away because their coefficients are not exactly the same and they're not opposite either, right? Remember, opposite numbers are same value, just the sign is different, right? So they do have opposite signs, but they don't have same coefficients. So we're going to go for x. So we'll eliminate x. And we will have to add because the x terms have opposite signs. So let's get started. We have x in the first equation plus negative x. And then we have minus 3y. And then plus 5y equals 9 plus negative 17. X plus negative x, as promised, that's a 0. Negative 3y plus 5y is 2y. And 9 minus 17 is negative 8. And here we go again. Y equals negative 8 divided by 2. Or y equals negative 4. So y equals negative 4. How about x? I'm going to use the first equation. X minus 3y equals 9. And I will substitute y of negative 4 in there. So x plus 12 equals 9. X equals 9 minus 12. So that would equal negative 3. So we're going to say that the solution to this system is x negative 3 and y negative 4. So far we've kind of made some observations. So if you look at the steps, they probably make a little bit more sense. So step number 1, we have to rearrange the terms, okay? That's the fun step. Now, step number 2, we have to make up our mind and we want to decide what variable to eliminate. This is where we have to think a little bit. What we want to do is choose to eliminate the variables that have the same coefficient or opposite coefficient. So why not make a note here for ourselves? So we're going to write here, choose wisely, please. So you want to eliminate variables that have either same or opposite coefficients. And opposite means same in value, opposite in sign, opposite coefficients. But this is only if possible, because sometimes that won't be possible. And that's not a secret. But we will learn how to deal with that in the next examples. And then we have to make a decision. We have to add or we have to subtract the equations, okay? So we're going to say that we need to add if the coefficients are opposite and we want to subtract if the coefficients are same. Okay? And then we solve the resolving equation, and then at the end we just find the other variable. So we use the other equation. We're going to move on to the next example. In the next example, we have again two linear equations, negative x plus 3y equals 1 and y equals negative 2x plus 5. Let's not waste our time and line up the terms. So I see that we have the x terms, they're not lined up, but that's okay. The y terms are here and the constants are here. So when I line them up, I'm going to start with the first equation, and I'm going to leave the first equation in the exact same form as is now. Negative x plus 3y equals 1. And now I have to match the second to the first, so I need to start off with the term x. The term x here is on the right side of the equation, so we have to bring it to the left side. The minus will make a positive. And then the y term is already in the left side. We want to keep it on the left side, so it will stay plus y. The constant term is already on the right side. We want to keep it on the right side, so plus 5. I know you will do this much faster than I am doing it now as I am trying to explain it. Now, the next thing we want to do is make a decision. Which variable do we want to eliminate? Remember how we made the decision. So we inspected each term. So inspect the x terms and check and see, do they have the exact same coefficient or opposite coefficients? Again, meaning that same value, opposite in sign. They don't. So we cannot just add or subtract in here and right away eliminate the variable. So maybe x is not that helpful here. So we'll stop thinking about x. We'll move on to y. So y terms have the coefficients 3 and 1. No luck here either. So we're going to think, what can we do? There is a way of solving the system very quickly. We just need to make a modification to the second equation. What we want to do is make a decision which variable we want to eliminate. If you want to eliminate the variable x, then you will want these two terms to have opposite coefficients. How can you make that happen? And you always have to think this way. So what do I want to have and how can I get it? And that's how it works all the time. So what I want to have is a number 2 in here. How can I get a number 2? Well, this is an equation. If I multiply by 2 every term in this equation, then I will have negative 2 here, positive 6 here, and positive 2 here. So let's do that. So we're multiplying by number 2. And we're allowed to do this, just in case you were wondering about it. Remember that the number 2 here will multiply every single term in the equation, left side and right side. And the equation will become 2 times negative x plus 2 times 3y equals 2 times 1. The second equation hasn't changed. And it's about time that I add something else to the process of solving a system by elimination. Whenever I make transformations to one equation, even if I don't do anything to the other equation, I still write both equations in each and every step, okay? I know it seems tedious, but it helps with keeping the information organized. Now, I will simplify the first equation, and you can use an arrow, just like this, to indicate the direction in which you are transforming the system. And we have negative 2x, that's 2 times negative x, right? Plus 6y equals 2. And then 2x plus y equals 5. And now we're thinking, okay, so let's eliminate x. It's about time. Do we add or do we subtract the equations? Well, since the signs are opposite, addition will allow the simplification of these two terms. So we're adding. So we'll have here negative 2x plus 2x plus 6y plus y equals 2 plus 5. Gan, 7y equals 7. That makes y equal to 7 divided by 7, or 1. So for the x variable, we can use any equation we would like to. Okay, we choose. And I would use the equations in the given system, and I really like this one because it doesn't have a lot of work to do. And we have in there negative x plus 3y equals 1. Negative x plus 3 times 1 equals 1. And negative x equals 1 minus 3. Negative x equals negative 2, and x equals 2. Now, I know that I showed too many steps in here, and in case you were wondering whether or not you can omit some of the steps, you definitely can. It's a very simple equation to solve, so if it is that simple to go for it. So we found x and we found y, which means that we are ready to state the solution, and we're going to say that the x would be 2 and the y would be 1, and that would be the solution to this system. I hope you are not tired yet, because I have one last example to go.